we can then continue. Okay, now we have the recording going on as well.
Good morning, good afternoon, everyone. It is my great pleasure to present at this important seminar today. The title of my presentation is about MCP and SECOM work in international organizations. Well, before we dive into the technical details of the SECOM and MCP, I'd like to take a step back and share some broader perspectives on digitalization from IALA's viewpoint. Today, the maritime digitalization is not merely about adapting new technologies. It is about building a global framework of the standardization and trust. I believe there are four major trends that are shaping the future of the maritime sector: automation, connectivity, sustainability, and digitalization. First thing is on the autonomous. Although the development of the MaaS is progressing more slowly than initially expected, the potential impact is significant. The autonomous technology could fundamentally reshape the maritime infrastructure and operations. That's why it is important to closely monitor its evolution and prepare for its eventual integration into the normal operations. By the way, the IMO MaaS voluntary code will be finalized in this year. Secondly, for the connectivity, although some questions remain, we already seen enhancements to the legacy systems, such as VDS and NAVDAT, that improve the existing service capabilities. On the VDS-related matters, the last IMO MSC approved the draft amendment to the SOLAS Chapter 5 and its appendix to introduce VDS, entering into force on the 1st of January 2028. And this will be adopted in MSC this year. Additionally, the rapid expansion of the low Earth orbit satellites technology is overcoming the long-standing cost and bandwidth limitations in satellite communications. As a result, connectivity is becoming more accessible and its application continue to expand. IALA is hosting a workshop in Edinburgh this week to discuss how coastal states can establish future radio communications and navigation infrastructure. And thirdly, addressing the climate change and supporting the UN Sustainable Development Goals are now essential considerations in every areas of the technical development. Lastly, about digitalization. Well, in fact, digitalization in the maritime sector didn't start just recently. It can be traced back to the e-navigation initiative, which began more than 20 years ago. The fundamental goal of the e-navigation has always been the harmonization of how marine information is collected, integrated, exchanged, presented, and analyzed. Within this framework, services such as search and rescue, pollution monitoring, and communication have been developed. I will explain the maritime services and technical services and product specifications in more detail in the following slides. But let me make one point here about the communications. We are entering a new era where the multiple data exchange channels are being available. This includes IP-based communications such as LEO satellites, mobile, and also non-IP-based communications such as VDS, AIS, and ASM. Among these, VDS is expected to play a particularly important role in enabling maritime digital communications in the near future. Just recently, IALA approved two important developments. First one is about VDS authentication and also VDS signal measurements. These steps mark a significant progress in preparing for a more connected and data-driven maritime environment. To enable digitalization and e-navigation, there are three main building blocks are required. The first building block is a description of the maritime services in the context of e-navigation. These define the services at a higher level, including their operational aspects. In a simple term, maritime services need to be described in a harmonized way worldwide. On the right side of the diagram, the second series of building blocks is product specifications. Harmonize the data format standards based on the S100 framework. The final building block shown in the middle is about how we exchange the data and information. This is where the IALA Guideline 1128 comes in, providing the standards for information exchange that make seamless communication possible. Ship-to-ship, shore-to-shore, and ship-to-shore. These relationships are not strictly one-to-one. A single service can connect to several others. With this framework in mind, let me now walk you through each building blocks in more detail. On this slide, let me show you how these elements fit together within the overall IALA framework. It summarizes the key IALA publications that define the maritime services, technical services, and product specifications, all of which collectively support the S100-based digital ecosystem. At the top, we have a standards 1070, which provides the overarching framework for the information services. Beneath that, there are two recommendations, one covering the maritime service and another for product specifications. However, at this stage, there is no dedicated recommendations for the technical services. For maritime services, we have a guideline 1155 and 1161, which describe how to develop maritime service definitions and evaluation platforms. For the specifications, the committee revised guideline 1106 last year, providing updated procedures for producing IALA product specifications. And for the technical services, several key guidelines are in place. Firstly, guideline 1128 on specification of technical services, and 1157 on web-based S100 data exchange, and 1183 on the provision of the MCP identities, and 1191 on the maritime service registry. Together, these standards and guidelines support the ongoing developments, both product specifications and the technical service specifications. Finally, we also have two testbed platforms supporting this work. For the product specifications, the IALA S200 test and validation tool, and for the technical services, the Open Digital Incubator, which enables testing and validation of the new service specifications. I would like to give you a little bit more detail on IALA publications. One of them is G1183 on the provision of the MCP identities. This guideline defines how secure digital identities are issued and managed within the MCP. It establishes a foundation for trusted maritime communications by assigning each entity a unique maritime resource name and linking it to the certified digital identities through a decentralized public key infrastructure. This document ensures that ship services and authorities can authenticate and exchange information securely in a global maritime environment. Another document I like to introduce is 1191, which specifies the technical design of the Maritime Service Registry, which is another core component of the MCP. The MSR allows ships and shore systems to register and discover maritime digital services securely through a standardized interface and trusted identities. Together with the 1183, it forms the backbone of the globally connected and interoperable digital maritime ecosystem, supporting the transition to the next generation of e-navigation and S100 based services. On this slide, I'd like to introduce the maritime service making the use of digital route exchange in terms of the vessel traffic services. In the VTS committee is discussing the potential use of the digital route exchange. This is still a work in progress, but at the moment, 4 possible services have been defined. The first one is a VTS route exchange service. The base for all others. It allows vessels and VTS to share a planned route in a standardized format, creating a common understanding and reducing the VHF radio load. And secondly, on the route reference service, VTS offers a recommended route in electronic format to assist mariners during the planning stage. And thirdly, a route cross-check service. VTS validates a ship's planned route against the local expertise, tracking factors like underkill clearance and the air draft before the vessel enters a critical area. And lastly, a route monitoring service. During the voyage, the VTS monitors movements in the real time to detect deviations and intervene promptly if hazards arise. Where these technologies are not developed in a vacuum, practical testing and validation happen through a global community called the Open Digital Incubator. Coastal states including Finland, Canada, Australia, and South Korea, and many other nations are already implementing these services in their own waters. They are proving that G1183 and also G1191 can work together to ensure a ship receives an uninterrupted digital services as it moves from a global port to another. In conclusion, the evolution of the e-navigation, the trust framework of the MCP, and the advanced VTS services we discussed today all share a single goal. That is to enable a safer, more economic, and more sustainable maritime future. Technology will continue to advance, but the trust and standards must remain at its core. Thank you very much for your attention.
Okay, that was Minsu's session, and all of the rest of the sessions today will be live, so you will have a chance to ask any questions you have for the presenter, and I will be sorry. I will be starting now with the first or the second part and start looking into the architecture of CCOM. And unfortunately, I'm on a very big display and I don't know how Zoom behaves, so I'll just walk you through these slides in this mode, but that should not be a problem. So I hope everyone is familiar with the term CCOM already, but just in case someone does not know what the acronym comes from, it comes from the term secure communications between ship and shore. And it is an IEC standard which is in the progress of being revised, and edition 2 should be published in some time. We'll get back to that shortly. But in short, the too long did not read section of CCOM is that it is a set of REST APIs, and it also then provides authenticity, encryption, compression, and various interactions between the actors in a defined manner. So it's basically a building block for maritime services. It is not an end all in itself. And this is something that I've heard from many people. I said it myself when I first started looking into CCOM, and that's that it looks complicated at first. But then the more I started working with CCOM and specifically started designing services around it, I realized that there is actually a good reason for why CCOM has its own complications. And we'll be going through a lot of that reasoning in this session now. But to continue on with the thinking of it being a building block, anyone in IT especially is very used to these kinds of layer diagrams where you have a physical layer, then you have a communication layer, which in this case, CCOM is one part of that communication layer. On top of that, you have an information layer, which is typically in this domain at the moment, S100 and S200 products. On top of that, then we have a function layer in which something is being done with the information that you receive or send, which could be navigational warnings, route exchange, traffic clearance, whatever. And then, of course, we have the business processes around this. But CCOM, like I said, is a standard set of REST APIs that define the interaction between the services and their consumers. It is extremely data agnostic. So even though the CCOM APIs themselves are JSON based, the payload can be anything because the data payload is base64 encoded. So it can either be a blob of JSON, a picture, a single GML file, or even an exchange set. So CCOM does not really say what the payload needs to be. And for this session, we're pretty much ignoring what the payload is. The payload is something. All of the communication is secured. There's TLS security by default required, and then all of the communication is also signed. And then, of course, it supports payload encryption, and we'll be going deeper into all of these. But basically, the idea behind trying to standardize around CCOM is to avoid a new version of the browser wars. Those of you who are old enough to remember, especially the early 2000s, when every website either had these kind of tags of best viewed with Netscape or best viewed with Internet Explorer or whatever, and they typically did not work on other browsers. That's what we want to avoid here. And also we want to make the life of the developers of both ship equipment and these maritime services simpler so that we have a single way of communicating from one side to another. Specifically having those building blocks of data signatures, compression, all of this in a standard way. And just to go through a few definitions so that we're talking with the same terms. A service in this context is a maritime service that provides a service, a technical service for consumers. For example, route exchange service, which is, of course, the hot topic at the moment. And then typically this kind of service is integrated with backend systems, for example, a VTS system. We don't really care how the service itself communicates with whatever system it has in its backend. It could be just storing things in a database, or it could be using another API to communicate with another system. That's out of the scope for us. The consumer then is a system that uses the service, basically some ship system or some equipment on board. This includes the ECDIS, but it could be any other computer system on board the ship. Then we have the standard HTTP terms of server and client. And in CCOM, both the service and the consumer have to be able to provide the client and the server, because we need to enable bidirectional communication. And we'll go more into detail on the reasoning for this soon. And then we have a term called vendor API. In the first version of these slides, in the first version of the workshop, we still had last mile here, but in the IEC working group that is working on the next CCOM standard, we're trying to get rid of the term last mile because it has been noticed that everyone understands it very differently of what it exactly means. And now we're just talking about the vendor API, which is one of the communication links, but in this case, specifically between the shore server of the consumer and the ship equipment. So all of this is hopefully a bit more clear in this diagram. And if we start from the left here we have a maritime service that provides some kind of data products, typically as an end result. Of course, it provides the CCOM API, which is on the HTTP server, and then it has the HTTP client, which is the CCOM client. Then we need to have some kind of shore CCOM interface, which has the CCOM client and its own version of the CCOM API. So this will handle the communication with the maritime service provider using IP connectivity. And then it has another direction where it can communicate with the shipborne systems via whatever means necessary. And here's the vendor API, basically providing this part of the link. Most current ship equipment manufacturers already have some kind of method of getting data to the ship equipment and getting possibly data back from there. So there's no need to start standardizing and requiring manufacturers to re-implement this side, as long as the CCOM data can be passed. And now what's new in the upcoming version, or at least in the current draft of CCOM Edition 2, is specifically the term CCOM Terminal, which then handles services an endpoint for the vendor API, and then is an application service in the 460 gateway that then enables the communication with shipborne equipment, which can include the ECDIS. One of the reasons why this is being done is specifically for type approval reasons, so that the ECDIS is communicating in a standard format which already exists, does not cause significant changes to current implementations as such, and also is easier to type approve because there is a stable boundary here, basically, which stays the same even if these maritime services change. And then, of course, we also have the other components of CCOM, which are the identity registry and the service registry, which are more defined in more detail in the ILR guidelines that Minsu already mentioned. And a reminder, if you have any questions, please raise your hand. I'll try to keep an eye on the chat as well to see if there's anything coming through there. But then on the side of CCOM is complicated. I'll still say, no, not really, even though it can look that way. But let's then start going through in a bit more detail of why does it look complicated and what's the reasoning behind it. So of course, the main thing that anyone working in the maritime sector already knows is that connectivity can be poor. Minsu mentioned that the current constellations of LEO satellites is helping solve this issue, but the issue still exists, and we have to build systems so that they are robust enough that the connectivity or the communication can work even though connectivity can be poor. And this is why the consumer's server may be on land. It could be on board the ship as well, but in most cases it will probably be on land, which is why we're calling it the Shore CCOM interface at the moment, so that it has a stable connection. That's a reliable party to communicate with, and then here in the vendor API side, there needs to be, of course, methods to handle poor connectivity. And then, of course, we have data compression as a part of the defined API. And this is extremely helpful when we're transmitting, for example, GML files or whatever that is text-based that typically compress fairly well, especially as S100 GML files are extremely verbose. Then, of course, there's the fact that it has to support asynchronous processes, because in pretty much all of the business processes in the maritime sector, we also have a human actor present there and a human actor making decisions. That's why we have the HTTP client and server on both sides. And then because of the poor connectivity, we can't use WebSockets, which are a more typical way in the current mobile phone era of handling asynchronous processes. That you just have an open pipeline between the server and the client and everything works. But with the issues with the maritime sector and poor connectivity and also some security requirements, WebSockets do not really work as a solution for this. And then, of course, we also have the fact that most of these business processes are not so time critical that there can't be some delay of minutes or even hours in between the decision making. Lawrence will shortly be going through the interfaces in more detail, but part of these asynchronous processes, we have upload link, get by link, access and access notification interfaces. And the issue is also, or something that has to be mentioned, that a simple synchronous get from the shore to ship is not ensured to work because, again, we do not have a reliable connection to the ship systems. Also, because of security reasons, we probably do not have a direct pipeline all the way to, for example, an ECDIS. So you can't do a synchronous get. And then something that is familiar to pretty much everyone who has a background or any kind of touch point to radio communication is the term closed loop communication. But if we have anyone from the IT world more who is not familiar with the term closed loop communication, it's basically when in radio communication, the receiver of a message repeats the key points of the message that was transmitted to ensure that everything was received correctly. In this case, we're not going to be sending back the data, but it is more important to be able to show that something has been delivered all the way to the consumer or to the recipient of the message that it has been delivered and possibly that it has been opened there. And the definition of opened is up to interpretation in this case. I do know that on the ECDIS testing standard, there has been specifically discussion that the definition is that it needs to have some kind of human interaction so that a route, for example, is opened. To make this, or to wrap this up in an analogy that everyone knows, Signal, WhatsApp, both of them, for example, have these ticks that you see when you send a message. The first tick that you send is, or the first tick that you see is the technical acknowledgement that that message was sent to a server. That's the end of the HTTP connection. The second tick that you get is the delivery acknowledgement that it has been delivered to the recipient's device or that piece of equipment that is intended to receive it. And then when the two ticks change their color, that means that it has been opened. Then, of course, we have a situation, especially with the Shore SECOM interface, that you might not always trust that party. So we need to support payload encryption. So even though all of the communication steps should be encrypted already because of the use of TLS, there is that intermediate server that you might not trust quite to that extent. So for that, we have a method of actually sharing keys and doing one-time encryption for the payload. Then another thing that needs to be supported is supporting the post of large payloads. We're getting very technical again, but all of these interfaces exist for a reason, and this is one of those reasons. So HTTP has no standard maximum size for a post, and it's very challenging to try to define a working maximum size for a post in an IEC standard, because we really don't know what all, for example, SECOM will be used for. So a workaround for this is that you do a post, which is typically an upload. For example, you're uploading a route. You get back from the server, you get back an error 413, which in HTTP terms means that this was too big. I'm not accepting this. So then what you do is you make the content available somewhere, and then you send a link to the recipient, and they can then do a get. And if you're at all familiar with how HTTP and the World Wide Web works, you know that basically you can load, if you are the client who is trying to get a resource from a server, it can be however large it is, and you can still get it. So that's a workaround of getting around the fact that a server might not accept a payload that is too large, but that you can still get it. Because, at least at this initial phase, a lot of, or most of the payload that we've been testing with is text-based, compression that is inbuilt in SECOM also might just save you. So I've done a test with an S421 route that has nearly 5,000 waypoints. The uncompressed size was over a megabyte, but it compressed to about 60 kilobytes. And 60 kilobytes will go to any HTTP server these days. So that should not be an issue. But still, there are inbuilt workarounds to support this situation. And then this is a use case that is probably going to be extremely rare, but it has been considered, and that's the need to support requesting asynchronous access. So the way, at least in the VTS committee of IALA, it was discussed there could be a situation where a VTS operator would already have a route from a ship, but for some reason they start thinking that, okay, I might not have been getting updates to this route. And if it would be technically possible, they could basically have the VTS system request an update for the route. This could then all the way be shown on the ship side as a prompt for the mariner to, okay, this VTS center is asking for your route. Do you want to share it or not? And they can say yes or no. So again, here's the synchronous part comes not only from the synchronous communication links, but also because it probably needs some sort of human decision making as well. But again, as mentioned, this might be a very rare use case. Then another significant part of the CCOM being a building block is specifically this, that it has a definition of a public key infrastructure for it. It uses standard X509 certificates. G1183 then defines additional fields that adopt it better for the maritime domain. And one of these additional fields that is defined is specifically the IMO fields where in the certificate you can have the IMO number and MMSI for a ship, which allows then shore systems to map the certificate to the, for example, the data received from AIS, etc. In CCOM version 1, a lot of this secure communication, etc., was done via MTLS. But then in development and testing that was being done, we noticed that there are some challenges around the implementation of MTLS from end to end. And now for CCOM version 2, the current draft is dropping support for MTLS, and the certificates are delivered as a part of the CCOM headers or the CCOM envelope. To walk through this pipeline, at the bottom or below this big blue arrow, we have standard internet security. So basically, all of the communication between a maritime service and a shore CCOM interface, or vice versa, is secured by TLS, in which the HTTP server's TLS certificate is from a well-known internet CA. Doesn't need any additional changes to any systems or any additional trust store issues or anything like that. That part will just work. But then for the payload, you can have a signature from a certificate that is received from an identity registry. Then it goes for the envelope to be signed. So this is the whole HTTP request that is being sent, be it a post or a GET or whatever. That is then sent and signed, and then we have the verification of the envelope signature on the recipient's side, and possibly the payload signature. And what's also important is that the payload and the envelope may have certificates from different entities. So for example, in Finland, we've developed a navigational warning service in which the payload is signed by the Finnish administration, Traficom, and then the envelope is signed by Fintraffic, who is actually providing the service. And then a bit of what's maybe missing from CCOM. CCOM version 1 has references to outdated algorithms. So revision 2 will update all of these algorithms, and also it's been written in a way that algorithms can be updated without updating the standard as recommendations change. Also, revision 2 is going to remove dependencies on consumers being registered in the service registries. The reason for this is just so that consumers are not, or the consumer endpoints do not have to be publicly discoverable, which hopefully increases security to some extent and also enables us to create pipelines in a way that the communication is specifically opened from the ship, and then the Shore SECOM interface can filter out any incoming messages that do not relate to a communication pipeline that was opened by the ship specifically. This is to help avoid the fact that you might otherwise be designing a system that would basically spam ship equipment with incoming messages that are completely useless. SECOM does not define retries if a call fails. That's left more for the logic of the business processes around everything. And then SECOM also does not define the business processes around the service. And that's then where the guideline from IALA G1128 specifically that describes how to write the service specifications and service designs for maritime services comes in. Those are more specifically, the service specification is specifically for designing and specifying the business process around the service, and then the service design is how you implement it, for example, using SECOM. And then quickly into a bit of what the future looks like. So, like I mentioned, revision 2 is under work by the IEC Technical Committee 80's Working Group 17. I noticed from the participant lists that I'm not the only one participating in this working group, but I would strongly recommend to begin implementing against revision 2 because there are enough changes compared to revision 1 that you don't want to have to re-implement everything. And the timeline currently is to get the voting version of the specification out by the end of the first half of this year. We're currently at the phase that the third commenting version should be sent out by the end of this month or in the beginning of next month, and we have a meeting to resolve the comments in May, and then hopefully we can get the CDB out. And then, of course, there is a fairly significant period of voting from the IEC members and then the publication phase and all of that. The timeline currently is extremely tight because the SECOM standard and also its sister standard, the S421, which is the route exchange product specification, need to be out before the ECDIS testing standard can go out to CDB phase. And that, of course, needs to be then get to the status of a published standard in time for type approval agencies to begin type approving the next generation of ECDISs so that in the beginning of 2029, they can actually be installed on board ships. But that's it for me. I will now stop sharing and I'll give the floor if there aren't any questions. And I can't see that there are. I'll give the floor to Lawrence Hughes from the General Lighthouse Authority research and development side to go in more detail into the interfaces of SECOM.
Hi everyone, thank you, Roman. I'll just share my screen. So, hi everyone. As Roman said, I'm Lawrence Hughes. I work for GRAD. We do research and development for the General Lighthouse Authorities of UK and Ireland. I've only been with GRAD for about 18 months. I've been working with SECOM for a fair amount of that time. So the presentation we're going to cover a lot of the Seacom version 1 endpoints and show what they're used for. As Rowan said, the version 2 is in draft and hopefully coming out soon, so we'll have a look at some of the changes that are there to see how it's going to be affected. So we're going to have a look at the Seacom context, which is very similar to what Roman's just gone through with the architecture, so we'll kind of gloss over that quite quickly. Then we're going to look at some of the Seacom interfaces, and we're going to kind of focus on the Seacom service interfaces a bit more. Look at some of the data structures that are used, and then show you what's available with the Seacom library on Grad's GitHub repository. And then finally, have a very quick look at the XML binding repo. So, Seacom is IEC specification, which aims to standardize the process, ships, and shore-side services used to exchange data. Seacom has service interfaces for data exchange. It provides some data protection measures, defines some interfaces that make services discoverable. And while it's been designed for IHOS 100 products, as Raymond said, it's data agnostic. It will transfer anything. It's all base 64 encoded. So yeah, it doesn't matter what's going through. So this is the same diagram Raymond showed. You've just got the data producers on the left, the consumers on the right, and then Seacom sitting in the middle, handling the data transfer from one side to the other. The Seacom API interfaces are kind of split into 3 distinct sections. First up, we have the Seacom service operations, which are aimed at getting the data from one side to the other. We have the get summary, the get, subscription, and then there's a few interfaces to handle large data transfers. The next section is the PKI interfaces. So you can perform a certificate signing request, check the status of a certificate from by getting the certificate revocation list or from an OCSP lookup. And then there's some management of keys as well. And then the last part is around the service registry. In version 1, there's just the one interface, search service, where you do your query, what you're looking for. Version 2 of Seacom brings in a concept of a global MSR search. So you query your local MSR, request it to be a global search. It will then contact all the other MSRs and get their results, and then you retrieve those results from that endpoint. The first interface in the Seacom services we're going to look at is the get summary. This just provides a list of the data products that are available from a particular service. You have some filtering options here. There you can filter on container types. So there's data set and exchange set. Data set is a pure XML data. An exchange set is a compressed zip file which is more compatible with ECDIS. You can request the information on certain types of S100 data, so S124 navigational warnings, 1258 on data. You can query for data product, geometry, which we'll cover a little bit later, UN location codes, again, cover later. The validity time duration of the data, and there's some pagination as well. So this is version 1 process. And then version 2, we're going to this summary filter object that gets put in an envelope so it can have a signature generated, just to add to a little bit more security to the payload. So in the GET interface, actually requests the data instead of just a summary of the data. The filtering options are very similar to get summary, except you've also got this data reference. If you've done a get summary, you get given a unique ID for each data set, and then you can just request that data set. And again, in version 2, we see this envelope come in and signature verification. Just actually to highlight as well, this is the exchange metadata object. So this is when Ramin said about you can sign the payload separately to the envelope. That's where you do that. That's where you put the signature for the payload and then the signature for the actual object, actual envelope. When you've got the data, if you want to be made aware of any changes automatically, there is a subscription interface that can be implemented. And it allows the user to request a notification if the information changes. Has similar filtering to GET and GET summary. So if, as I say, if there's a change, the service will upload the available data to the customer, to the consumer straight away. And they will be made through the notification interface. You create a subscription post to this interface, and then you can remove it with a delete later. If you have a subscription and the data changes, the service will push that information to the consumer by the upload interface. So this would be implemented on the consumer side. And yeah, the upload object is encapsulated in an envelope and signed. Yeah, then they can request that acknowledgement that Ramin spoke about with the signal example, which is this field here, request an acknowledgement. The data size limit for upload is about 350K of base64 encoded data, which is quite small, but again, it's that unreliable comms issue. But if you have a larger transfer, there's another interface you can use, which is upload by link. So the idea here is that the data provider will make the data available somewhere and just send a link to the consumer to tell them where they can get it. They will also include how much data there is and how long they have to download it. This again is in an envelope and signed to check it's valid. So when the data consumer gets this, they then go to the get by link interface on the data producer with their transaction ID, they can get the data. In version 2, this upload link stays the same, but the get by link just has this envelope added again. This is something we see a lot in version 2, that the data just gets put into an envelope so it can be signed. Another interface, this one's quite simple. It's just a ping interface, and it's just used to check that the service is still running, still healthy. It's used, I believe it's used by the service registry to check that the service is still running and still happy. In version 2, there's just a change to this attribute name. And the date time is actually optional. Okay, then we have a capability interface. Obviously, there's a lot of endpoints interfaces that are not essential. So the capability interface just tells you which ones this particular server has set up and is able to provide. And this is very useful for automation, checking that you're not going to do a request to a service that isn't there. So if there is no upload link service available, then you know that you can't do that in. Version 2 is very similar. There's just an extra interface, public key, which is just used to share public keys between client and server. So now we'll look at the important data structures in CCOM. The date times have changed between version 1 and version 2. Version 1 was using the S100 format, and then version 2 has changed to this ISO 8601 format. It's just more standard. Yeah. Then the exchange metadata, which I showed earlier, that will tell the client if the data is encrypted or unencrypted, what protection scheme is in use, what algorithm was used to protect the data so they can verify it, the digital signature for the data, the public certificate that was used to sign it, and then if there's any compression on the data. Another one is the universal unique identifiers. These are usually a lot for data references. There's a need for these to be mapped to dataset identifiers and potentially MRNs. Are assumed to be service specific. They're a fairly standard ID system, used everywhere really. The geometry that I mentioned in the get summary and get queries is a well-known text visualization. And we use this so that you can request just the data you're interested in. So if you were to just do a search on our ATON service, with no geometry. You see there's 3 data sets here. There's English, Irish, and Scottish data sets. That if you then plotted route from Aberdeen, I think, to Land's End, and included that in your query, you just get the English and Scottish. Doesn't give you the Irish because you don't need it. And then you can just download the data that's needed for what you're doing. Then there's these UN low codes, United Nations Code for Trade and Transport Locations. They're largely land-based identifiers. Not sure how much they'll be used, but they're there and they're all on PDF if needed. So yes, it does look very complex, and you know, when I started in grad, I thought it was very complex. But yeah, as I've worked with it more and more, it makes more and more sense. There's a lot of areas that you know you kind of you write once and you can reuse it everywhere. You know, it is just these 4 components really, and if you write the security bits that generate the certificates, generate the signatures, you know, you can use that for every object. The data structures, you know, there's a lot of them, but there's nothing. And again, the envelopes, you know, you kind of reuse concepts and reuse interfaces, and yeah, it's not too bad. But it is ideal for reusable libraries, which we provide on our GitHub page under CCMLib. So the CCMLib repo on our page is a Java library. It gives you the full CCM functionality out of the box. It's integrated with Spring Boot. There's version 1 and version 2. Our version 2 is actually based on a draft that came out last year, and it is a bit out of date, so we will look to update that shortly. I think a lot of those envelopes that I've shown weren't in the draft we had, so there are some fairly significant data changes for us to set up on that. But it's there if you want to start looking at it. You can run both versions simultaneously. Just add them to the Maven POM file. It gives you everything. So when you import the repo, you can then we have a lot of interfaces, Java interfaces set up for all of the API endpoints. So you implement that interface and it will then add all the error handling. You just have to write the method that gets whatever data the endpoint needs and responds with it. Maven packages are here. So if you add our repos, you can then add, that's the version 1 library, so you can, and then that's version 2. My colleague was working on Spring Boot version 4 update a few days ago, so hopefully that will be on there soon too. And this is this is our GitHub page with the CCMLib. You can clone this or take a fork and work on it yourself if you prefer, rather than use our repos. The master branch is version 1, and then there's a version 2, which is, like I say, the out-of-date version 2 draft. Yeah. So now we're coming on to the XML bindings. So SECOM is primarily intended for S100 data exchange. There is an embedded data product type attribute. And there are XML schemas for those product types. So there's been some work on an XML binding repo, which is here, is hosted on the IHO page. Then we have various specifications and bindings. Any that are on IHO's website will be picked up automatically, but there are a few missing, like the S125, S201, so they can be put into the repo separately and then accessed. And then this is the IHO binding repository. Right, so I think that's it from me. I don't know if there's any questions at all. No. Okay, well, yeah, thank you very much. If you do have any questions, my email's there. Feel free to reach out.
Thank you, Lawrence. And I don't think it was mentioned, or I don't remember if I mentioned it earlier, but the presentations will also be available on the Digital Incubator website at some point of time soon. Now, next up, we have Martin Richards Serda from the Canadian Coast Guard to talk about an actual implementation and walk us through that. So, Martin, please.
Hello, do everyone hear me?
Yes.
Yes, okay, good. Hello. So I work for the Canadian Coast Guard. I'm a project engineer there since 2018, and I was in the team that has implemented the S124 service implementation based on SECOM, as Ramin has been explaining earlier, and also we have used the SECOM Java library. So I've prepared the presentation. So just let me 2 seconds to share it. So let's see. Let's share my screen there. And then please let me know if you see something. It will be much appreciated.
We do.
Do you see something?
Yes, we do.
Okay, perfect. So let me find how to put it full screen. Just 2 seconds. I'm sorry, I had it before the presentation and I've just lost it. It was control something. I think it was this one. No, okay. Just give me 2 seconds. Okay, there. Okay, it was Control L. There we go. Okay, thank you. So is it still correct? Yes. Okay, so if there's something, just let me know. So for the implementation, so I will show you an overview of the architecture that we have been using for this project. I'll talk about the SECOM Java library, the Spring Boot framework that we have used, the GXCB library as well, that I will explain later, but makes the mapping between the data and also the object we use in the Java language. I'll also show you how to interact with our service. So there are HTTPS REST requests, and I'll show you the dynamic documentation, which is based on OpenAPI. Also show you a little bit how the responses look like and the content also. And finally, I'll talk about the MCP, the Maritime Connectivity Platform that we have used to create our identity and have the certificate to validate the signature in our data. So, okay, so as an overview of the architecture, so in the first place, we have our own system that we use to create, handle, cancel, and publish the navwarms. It's based on the NIAV project. So it's a kind of fork that we have modified it to satisfy the specific Canadian requirements. Then associated with that, we have the database that contains all the navwarms we create and we publish. And from that database, we had a first version earlier before the S124 service that we used as an exporter to create S124 products. But then we have added the solution of the S124 web service based on SICOM. That service, how we can describe it as it's shown here. First of all, it is registered in the MCP connectivity testbed for the moment, and then from there you can search for our service, find it, and then use the contact our service and use its interface, and so for the end exist user or CS users, they can find us with the MCP and then communicate with our service. So as an overview, I think it's a good summary of how it works. So as I said previously, we have used Java, the main language, and from there we have used the SICOM library that the presentation just before me described, which has been developed by the people we have just heard. Personally, I know a little bit more Nicolas, but the person just before me is part of his team as well. And here it's how we import the SICOM library in Java using the Maven tool. So it's here a screenshot of that. Then once we have imported the SICOM library, then we can use it. So how we can use it? We first have to implement the interfaces that are defined by the SICOM library. So one of these interfaces here, that we can see get SICOM interface. So we implement it, and we then have to use the method defined by an interface in its parameters as well. So in the second screenshot here, we have, for example, all the parameters that are defined by the get SICOM interface, which comes from the SICOM library. Then it makes sure we use the required signature exactly as defined by the SICOM library. So the next here screenshot is just to show that we have also used the Spring Boot framework in Java. The SICOM library also uses it, so we have to import it as well to implement our service. And here the next screenshot, it's to show you a little bit what is the GXB library, which is another library that we have used, but this one is really to make the mapping between the data, which when we load it from the database, we convert it as Java objects to work with them, to work with these objects. And from the Java objects, to convert it as a XML content, which is how the S124 data is formatted. Then the GXB library, when you define the classes, in the way here we have in the screenshot, then it's able to convert the Java objects into the final XML content in format, which is how the S124 data is defined. So that makes the mapping very in a very useful and optimal way. So there, here is an example how I create an object in Java to set the values in the object-oriented way. To, after that, use the function that will come from the GXP library that will convert it in the S124 format, just as I explained before. And then, so once we have implemented the REST methods with OpenAPI, we can interact with our service to see how the responses are and how the parameter works, for example. So here is the version with screenshots, but I can show you the version with the navigator, which is more dynamic, just to show you how it works. So please let me know if I lost you or if you lost the image, please. I'm just going to make some room here. Okay. So I hope you still see something. So if there's any problem, please let me know. So here it's the OpenAPI page of our service. So for the moment, we have mainly implemented the summary method and also the get, the general get method. It has been described in previous presentations. So if I open here the description of the summary request, so we have here, I can click on try out. So here we have all the parameters, the available parameters. So the product version, the geometry, we want to restrict our search for navworms, for S124 navworms for a specific area, for example. The dates also. So if we are looking for navworms from a specific date until another date, we can add them there. And we can use also the page and page size parameters to restrict the number of results, because here in Canada, we are a very large country and we produce a lot of navworms. So in our case, for example, it can be very useful to restrict a little bit the results. And so yeah, so let's give an example. I'm going just to limit the results to avoid to have a too huge response. So let's limit it to 10. So if we execute it, so the request here looks like that a little bit, what we have sent to our service, and our service responded with this response just here, a little bit here. So this version is version 1. We have version 2 also, but it's not in production yet. It's still in the dev environment. So here, the version 1. So we have these fields, a field for the data reference. It's a list of the first 10 S124 navworms returned by our service. So here, the first one, it's data reference. Is it data protection, data compression? It's not compressed for this one, no. The project type is 124. Its series here in Canada. Its title, its status, published. Its textual description here, and its last modified date. The available version so it's available as the version 2.0 by default of the S124 data definition, and its size. So here the second one, the third one, and yes, so the first 10 results. So that's as explained before, the summary request is like a light version of the data. We don't have positions. We don't have other more heavy details. So you want to get all the details, we can do the same thing, but with the full get method, which is located a little bit, I think it's just above. Give me 2 seconds. So we are going to close here. This one, and this is the second one. This one, it's for the more detailed get function. So the parameters are very similar. We have one for a geometry, for dates if we want some ones limited in a time interval, date time interval, the page. So for the same reason, I'm going to limit it to 10 results. And so if we execute it, so here we have the what Ramin was explaining as the envelope, or maybe the transport format of the data, if we can call it like that, defined by SICOM. So we have a field which is for a data. So for the first result here, it's encoded in base 64 in the base 64 format, and the information of the S124 of that first S124 nav1 is encoded there here. I'm going to show you to decode it just after that, but I'm going to show you the other fields before. We have a field exchange metadata. So here, for example, we explain which algorithm we use for the signature. We have the certificate that we can use to validate if the signature is correct, is valid, and the value of the signature that you can validate using the algorithm shown here and the certificate that we have here, which has been generated with the MCP identity registry from their test bed. So yeah, so now that I've shown you the general fields returned by the general get method, I can just decode it, show you how it looks like. So if we take here, and here we have a tool, online tool, to decode text from the base one. From the base 64 format. So if we paste it and then we decode it, then we have the following result here at the bottom here. So it's the final S124 format of the first result of the first S124 nav1. So we have the tags here in the XML format. We have the different fields that identify that single S124 nav1, the title here, its series, that's the topic category defined in the S100 standards. Also, well, the chart number in this case, the publication of the chart, the publication name of the chart. Also, if we go further, we have the agency, which is us, Canadian Coast Guard. the name of series, the warning number of the series 202 for in this case, the title here. So the language by default it's English. It's title of that navwarm. The cancellation date if defined. In this case, it is defined. And then after that the dates. So because of the cancellation date, it has an end date, a start date. The full description here, the full textual description, and also now it's the geometry. So the information that we didn't have in the first summarized request. So here it's full position. For this case, it's a point. So let's see. I think it's a little bit, it's hard to find out there. Here, it's coordinate, but it's just a coordinate because it's a point. So it's how it looks there. So if I go back from the dynamic documentation of our service, so here the first result. So we have the same thing for the second result, third one, and etc. And then we can add other parameters to restrict the results, as I was explaining. And then what else? Yes, I can maybe show you. We have a parameter container type. If we, by default, it's the full raw format that I just showed you. But if we put 1, then we will have the exchange set format. So I can maybe just show you because it's different a little bit from what I've just showed you. So here, if we execute it again, the 10 first result, but with the container type set to 1 to have the exchange set, then there we have. So it looks like just one result in this case. So the data field is very, very heavy, and there's one result, but that result actually contain the zip file content of the exchange set. So I'm going to decode it. So it's encoded again in base64. Here I have a tool to convert base64 content to file. So let's try it. There we go. So I can download it here and then show you how it looks like. There. Yes, okay. So sorry, it's a little bit too quick. Okay, so here is the file. It's a zip file. So it has a S100 root folder, then the catalog, the XML catalog file, which is based on the X100 exchange set, and one S124 folder, which contains a dataset files folder and all the single files associated with each in single navwarms that are from the request. And the request we had asked for the first 10 results again. So there are the 10 first 10 results of the request. So I can maybe open just one quickly to show you how it looks like. So let's hope you can see. Just tell me if we have some problems. And here we have the S124 format of the first file, for example. So it's very similar from the other format, but now it's structured as a S100 exchange set. So here the first content of the file. And maybe quickly I can show you also the catalog file. If I go back, I guess you know it already. Just give me a second. Yeah. So the catalog file looks like it has information for every single file that it contains. So for example, here is the first file with its signature. And yeah, so that's the catalog file. Yes, so I can go back to my presentation here. Okay, so I've showed you a little bit how the service looks like, how we can interact with it. Yes, so that's what I've shown you. And finally, as I explained a little bit very quickly at the beginning of the presentation, we have created our identity, Canadian Coast Guard identity, in the MCP, so Maritime Connectivity Platform Identity Registry. So if you connect to that identity registry, you can find us here. And with that identity, we have been able to generate a certificate and a private key as well. So we use the private key to make our signatures, and we give our certificate in our responses to let the end users to validate the signature with the certificate that we have generated there. So here is a description of our identity, Canadian Coast Guard identity that we have created. Yes. And here it's a Maritime Connectivity Platform Service Registry. So the service I've just shown you with the Open API documentation, you can find it here and see, for example, what's the exact URL to connect to our service. Here it is. We have also the zone that our service cover. So in Canada, yes. And yes, and that's it. So I hope it has shown you how it looks like an implementation of using the SICOM the SICOM interface and SICOM standard. So that's it for my presentation. Just let me go back. I'm sorry. I have okay. So yes, just listen. Let me. I'm going to put it. I don't know how to stop the sharing screen.
Thank you, Martin. There should be at the top of your screen maybe a red button.
Let me. Oh, okay. There, I think. So let's see. Okay, I think you still see my screen, right?
No, no, we don't.
I stopped it for you.
Oh, okay. Okay, perfect. Okay, thank you very much. So I'm sorry, I'm not very used with the Zoom. So thank you very much, everyone. If you have any question, just let me know. And yeah, so thank you.
Thank you, Martin. Next up, we then have Per Deflon from Sweden to present a slightly more complex case with a bidirectional service. And this is a demo of route exchange. It does not exactly conform to the route exchange service design and the specification from Ayala, but it has much of the same components. So, well, I could talk quite a bit more about the route exchange, but I think it's enough if Per starts going through the demo, and we'll hope that his voice will last as he's recovering from the flu. But Per, up to you.
Thank you. See if you see.
Yes, we see your screen.
What do you see now? You see the presentation now?
Yes.
Okay, good. Since I'm on my laptop screen, I need to just hide this Zoom window. Can I do that? Put it there. Okay, hello everyone. My name is Per Deflon. I'm a technical consultant for SMA, Swedish Maritime Administration. I've been there now and then since 2014, when I started working with the STM project, which was the project prior to the SECOM initiative, and I also been part of SECOM working group 17 working with edition 1 and now the next version of SECOM. Yeah, so I will take this opportunity to show you the SMA implementation of the SECOM instance, and also of the private or the vendor API or the last mile or whatever you want to call it. This is going to be published as an open source available as soon as the law side at SMA are ready for every investigation that's needed, obviously. But looks like we're gonna release it very soon. So this is a .NET implementation of SECOM as opposed to all the Java libraries available. And what I will try to show you in this demo is a bidirectional route exchange simulation. And it's a simplified use case where we have a ship on the left side and we have a VTS or service provider on the right side. And the backend applications of both these actors is a simple web UI with a backend and a database. And then I have two SECOM instances running, from one of each for the VTS and one for the vessel. One of them are running in debug mode, so we can look at some code. And they also have two private APIs running, and one of them also in debug mode. And they have their own database. And there are clients on in the application layer as well as in the service layer. So the route exchange is initiated by the ship deciding to share its monitored route in this case, or a planned route. And the ship is doing that by, in this case, we are simulating what Ramin previously said about having different certificates for signing in the application and in the SECOM domain. So in this case, the ship will sign the payload data already here in the backend, and then it will send a partial upload object to the private side. The private side will continue building the complete upload object and also adding the envelope signature. And finally, it will consume the VTS upload interface. Also in this, we have a requirement from the ship that the receiver should send two acknowledgements to confirm this exchange. And one is the delivered acknowledgement and one is the opened one. The delivered acknowledgement is sent when the backend application pulls the received data from the SECOM instance, and at a successful transaction between these, the private API will, through its SECOM client, automatically send a delivered acknowledgement to the ship's SECOM, to the ship's acknowledgement interface. Later on, an end user will open the actual message and manually send an open acknowledgement. In this case, consuming its private API side, the private API will forward this acknowledgement and once again populate the acknowledgement endpoint of the VTS vessel. Sorry, and that will close the loop for one side. And the next step is for the VTS to send a route to the ship, but we can come back to that. Okay, so I will start by taking up this this client application. So here I have already stored endpoints for this service, which is running on my local host. I can ping it. I got a green light, meaning that this is online. I will, as a ship, I will upload and I will choose one of the 4 possible ACK requests. We don't have any container. I will send a bare GML file as a S421 product type. And finally, I will select the binary or the XML. And now, hopefully, I will pass some. Here's the backend. We're still in the application. And you see here in the code, we have generated the signature for, in this case, the payload. And in SECOM, we always want to sign the original data payload. So we save this original data before any possible compression or data protection. In this case, we know how to verify the same signature on the receiver side. We can look at this object. This is not the full upload object needed in SECOM, but it's part, and we have the digital signature value here, coded as a hexadecimal string. And now we can continue. Now we're at the private side of the ship's, or the vendor API of the ship endpoint. We have now built the complete envelope object. And we have added, oh, sorry, we already have the data signature. We have added the, where are we now? Sorry, we're still in the client backend. I should press one more time. Now we're in the private or the vendor API. Sorry if I'm scrolling too fast. So this is the final upload object that we have built now in the it's not. I don't understand. Where am I? What can go wrong with a live demo? I thought that was in. I got some. I thought I got the timeout exception, of course. Oh, that's why. Oh, let's see if something happened here. Oh, this is the private side. So I was staying too long. Okay, this is the envelope signature in the vendor API. Now we're in the vendor API. Sorry, I have too many windows with Visual Studio, and the final thing I will do is create a HTTP client request, and okay, now I did send that, sorry, and now we're in the receiving public side. This is the vessel SECOM public interface. I was too quick. So this is the post upload object in the SECOM, and we do some validation. We are validating the model state and the data type, correct data type according to the capability of this service, or this in this case the vessel. Here we are doing a schema validation for the S421, and that should work. And we also check the size as we they were mentioned before. This was not so big, and we have a max limit that's for our web server. We also check if the certificate from the MCP identity registry is valid. It is. And after all this, we can store this data in the database. So here we have the database. Now it's stored. It seems like I don't know what's happening now. Okay, I don't know if I uploaded more than one message. I thought there was only one. So this is the ship. Now we should look at the VTS side. Yeah, okay. So for some reason I did upload three messages, which was not my intention. And now, as I told you before, when I do this get from the backend now, here, this private API will automatically invoke an acknowledgement, delivered acknowledgement. So first, I will go here. And here I downloaded all three of them. So we can have a look at some of it. They have different transaction IDs, of course. Take this one. And I don't have the private side of the VTS in debug mode, so I need to look at the log. Can look at the log. And we have here we have the acknowledgement. So this is the private side sending delivered acknowledgement to, in this case, the 4001, which is the vessel SECOM public endpoint or base URL. This is the acknowledgement object. We have an envelope, and we have this transaction ID identifier, and we have the envelope signature lastly here. And we get a response from the vessel acknowledgement endpoint saying that it was successfully delivered. So that was working. Now we can go to the vessel to see if we have a notification. And since we managed to send 3 messages, which was not my intention, we got 3 delivered acknowledgement back, as you see here. Okay. So the final step for the VTS was to open. So let's open the last one. So we can look at the content of this S421 route. I'm not going into details. We have a map that we can look at also. So this is the route going from Helsinki to Denmark. And as we see, it's going north of this small island, which is Bornholm. And we can also see here in the UI that we have successfully sent a delivered acknowledgement. We also need to send an opened acknowledgement, and I will do this now. Send an open ACK, and I will go to the vessel. And there we got this. Okay, so now the vessel knows that the VTS has opened and read the monitored or the route, shared route. Now we will do the same thing, but from the other side, the VTS. Hopefully I won't send 3 messages. So in the service registry tab, we have stored the endpoint base URL of the ship. We can ping it. It's working. Here's the, oh, sorry, ping. Yeah, the ship. Yeah, so here's the ship public. You see here we have a request for the ping, and it was successful, and we got the green light, and now we can do an upload from the VTS. The same thing, we want an open and delivered acknowledgement. We're going to share S421, and we have a proposed route. So we're just going to send that. Oh, it's faster. Okay, so now we send the proposed route to the ship, and then we need to go to the ship, and we can go here, and now we're in the private side of the ship where we get all messages, and we see here that at this response, if that's okay, we will send an acknowledgement. And like that. And now we should see on the ship, suddenly we got one route. We have sent the delivered ACK to the VTS. We have notification that we got one new S421 message with this transaction identifier. We can have a look at the VTS side. VTS side has got a delivered acknowledgement from this service MRN, which is the vessel service as said in its certificate or identity in the PKI MCP system. Back to the SECOM ship application, and we're going to have a look, of course, at the proposed route. And now we see that the VTS wants the ship to go south of Bornholm instead of north. So these 3 endpoints has been changed. Now it's up to the ship to accept these changes or not. It's up to the mariner or the captain. We will send an open ACK as requested. And now I won't show you any more logs. So we already, this is the same thing that is happening. Now we have been sharing a route from the VTS, and we have sending acknowledgement back from the ship. And look at the VTS. And you see now we got the opened acknowledgement received, and that closes the loop. And that's about it for this demo. Questions?
Thank you, Per. It appears our audience is as active with questions as it was 2 days ago. That no questions, but
hopefully it was. It's complicated to try to show you live demo with too many windows, so especially on a small laptop screen.
yeah.
May I ask a question?
Of course.
Is there going to be a reference implementation for any of these? As this appears to be pretty standard.
Yes. You mean the ones I show you now?
Yes, effectively.
Yeah, yes. The intention is for SMA to release all of these components, as I showed you now, the SECOM implementation, and also the private or the vendor API implementation, and also the web app with its backend system and databases and everything. That's the intention to release everything as open source. Yes.
Excellent. Thank you.
Thank you.
Okay. So thanks, Per. Before we wrap up, just a few notes on the digital incubator. Since all of you found your way to this seminar or to the workshop, you've heard about the digital incubator at some level at least. It's a very free-form collaboration platform, or a platform, or basically an environment where different actors in this space can now collaborate with each other specifically for testing purposes of the services and everything else. So if you want to join, we have bi-weekly meetings, which typically last anything from half an hour to up to 2 hours, depending on how active the discussion is. But on the website, there's Thomas's email address, so you can contact Thomas to be added to the mailing list and get information on the meetings. I have to say that specifically the discussions we've had around various service specifications, the designs and various implementations has helped both in the work of defining the services, but also then feedback received from developers has also been returned back to the IEC working group for improvements to the SECOM standard as well. So currently it is a really good place to share experiences and possibly ask questions if there's something that's bothering you with an implementation detail. On that note, since we don't have any other tracking of who is present or not, if you have any feedback to give us, please write a comment so that we can store some sort of feedback from at least some of you. And on that note, I'll wish everyone a good day, good evening, good night, good morning, depending on whatever time zone you are in. And
Thank you.
Thank you.
For listening.
Thank you.
Thank you, everyone.
Bye.